video, we are going to explain about a project titled A Software-Defined Network-Based Security Assessment Framework for Cloud IoT. Coming to the introduction part, as the integration of cloud and Internet of Things, that is Cloud IoT technologies, continues to grow, ensuring robust security measures become paramount. Traditional security approaches struggle to keep pace with the dynamic and complex nature of cloud IoT environments. To address these challenges, a groundbreaking solution emerges: a software-defined network-based security assessment framework. This innovative framework leverages SDN's flexibility and programmability to enhance security in cloud IoT systems. By decoupling the network control and data planes, it enables centralized security management and real-time adaptability. The SDN-based security assessment framework empowers organizations to identify vulnerabilities, detect anomalies, and respond rapidly to potential threats. Through this cutting-edge approach, cloud IoT security reaches new heights, instilling confidence in both businesses and end users regarding the protection of sensitive data and critical infrastructures. Leveraging the principles of software-defined networking, the framework introduces a centralized and programmable network control, revolutionizing how security is managed in cloud IoT ecosystems. This centralization empowers security administrators to have an overarching view of the entire cloud IoT network, granting them unprecedented visibility and agility in monitoring and responding to security incidents. So our main objective for this project is the software-defined network-based security assessment framework for cloud IoT is to establish a comprehensive and adaptive security solution that addresses the unique challenges posed by the integration of cloud and Internet of Things technologies. Traditional security approaches often struggle to keep up with the dynamic and diverse nature of cloud IoT environments, making them vulnerable to emerging threats and attacks. This innovative framework aims to leverage the inherent advantages of SDN, such as centralized control and programmability, to create a more resilient and responsive security infrastructure. By decoupling the network's control and data planes, the framework allows for centralized security management, enabling real-time analysis, monitoring, and enforcement of security policies across the entire cloud IoT ecosystem. This adaptive and context-aware nature of the program is crucial in safeguarding cloud IoT systems from potential cyber attacks. A key aspect of the framework is the centralized coordination of security measures across different components of the cloud IoT infrastructure. By implementing a unified security approach, the framework ensures consistent and cohesive security management, reducing the risk of security gaps or inconsistencies. Now coming to the requirements part, hardware requirements and software requirements is required for running this project. First, operating system as Windows, processor i5 and above. Minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Coming to the methodology part, first we have upload expert survey dataset. This step in the process is to upload the expert survey dataset, which contains data collected from domain experts or security professionals. This dataset likely includes information about various security features, vulnerabilities, and threat indicators relevant to the cloud IoT environment. The dataset serves as the foundation for the subsequent security assessment and ranking process. Second, read and process dataset. Once the expert survey dataset is uploaded, the framework reads and processes the data to extract relevant features and attributes. This step involves data cleaning, transformation, and preparation to ensure that the information is in a suitable format for further analysis. Third, run LTR, that is Learning to Rank module. The Learning to Rank, that is LTR module, is an essential component of the security assessment framework. In this step, the framework employs machine learning algorithms to learn from the expert survey dataset and rank different security features or indicators based on their importance and relevance. LTR algorithms help identify critical security aspects, enabling better decision making during the security assessment process. Fourth, run ADA rank module. ADA rank is a specific ranking algorithm used to optimize the ranking of security features based on their importance and relevance learned from the LTR module. This algorithm iteratively refines the ranking to improve its accuracy and effectiveness. The ADA rank module plays a crucial role in ensuring the most critical security factors are given higher priority during the security assessment. 6. View security results. After the LTR and ADA rank modules complete their processes, the framework presents the security assessment results. This step allows stakeholders to view the rank list of security features, vulnerabilities, or threats indicators based on their importance and relevance. The security results provide valuable insights into potential weaknesses or areas that require immediate attention for enhancing the security posture of the cloud IoT system. 6. Require or not require graph. The framework may generate a require or not require graph as part of the security assessment report. This graph illustrates the correlation between different security features and their significance in the cloud IoT environment. It helps stakeholders understand which security measures are essential and which ones are less critical, aiding in resource allocation and decision making for improving the overall security architecture. Now coming to the execution part. To execute the project, first we need to open the code folder. So here you can see we have two folders that are PyCache and survey data. So in PyCache folder, we have some Python files which are containing Python scripts code. In survey dataset folder, we have a dataset with the extension of .csv. And here ADA rank matrix, SDN cloud IoT security and models are the Python files which are containing the Python scripts in it. And here, this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here, this is the graphical user interface. With this, we are interacting with our program. Now, click on upload expert survey dataset button and upload the dataset. Select this dataset and click on open. Here you can see dataset is loaded. Now click on read and process dataset button to read and process the dataset. Here on this screen we can see dataset contains 23 security features and for each feature we have ranking from 46 experts. Now click on run LTR learning to rank module button to give ranking to each features using LTR algorithm. Here we can see LTR ranking for each feature. Now click on run ADA rank module. To predict which security is required, experts give more preference and which security features not required, experts give less preference by checking ADA rank. Here we can see ADA rank processing completed. Now click on view security result button to get prediction of each security features. Here we can see features name and below it we can see ADA rank weight value and then that security required or not required. Here we can see antivirus and anti-malware feature required and scrolling down the above text area we can see result for each feature. Now click on require and not require graph button to get the graph. X-axis represents features type as requires and not requires, whereas Y-axis represents count. From this graph, we can conclude that out of 23 security features, experts want require 10 features and not require 13 features. Each security feature is called as indicator. Now coming to the conclusion part. In conclusion, the software-defined network-based security assessment framework for cloud IoT represents a significant leap forward in addressing the security challenges associated with the integration of cloud and Internet of Things technologies. By harnessing the power of SDN centralized control and programmability, the framework offers a robust and adaptive security solution that is well suited to the dynamic and diverse cloud IoT environment. With its real-time monitoring capabilities and advanced anomaly detection techniques, the framework enables organizations to identify potential security breaches and emerging threats promptly. This proactive approach empowers businesses to respond rapidly to cyber attacks, minimizing their impact and reducing the risk of data breaches and system compromises. Furthermore, the framework's ability to enforce security policies consistently across the entire cloud IoT ecosystem fosters compliance with industry regulations and standards. This ensures that organizations meet the necessary security requirements, enhancing trust and confidence among stakeholders and users. The centralized coordination of security measures across different components of the cloud IoT infrastructure ensures consistency and cohesion in security management, reducing the risk of gaps and vulnerabilities. This unified approach enhances the overall security posture of cloud IoT environments and facilitates effective collaboration between different security elements.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.